Hey everyone. So you might notice a new look, right? And you may even notice a better sound, right? As you know, I kind of made those videos last night at 2 a.m., right? So, and just so we all know, like, this is just me freeballing off the top of my head, right? Because I really like this topic, right? And I don't see it get enough justice, right? So these videos, just to keep in mind, they're not lecture notes. I did not type any of this up beforehand, and this could be pretty obvious because, you know, last night I did make an error, right? Because like I said, I don't know the formulas anymore. So cosine squared of x is actually equal to not the square root of 1 plus cosine of 2x over 2, but it's actually just the stick with the square root. It's just that, right? So anyways, you know, let's move on, right? So new look, new everything, right? So today, this video, we're going to focus mainly on what is sine of x plus y. Now, if you're an engineer, if you're an electrical engineer for sure, you do a lot of things with these trigonometric functions because they're sinusoidals. You may have this memorized, right? I'm not an engineer. I don't have these memorized, right? Because I use Euler's notation a lot. So what we're going to do today's video is how can I use this to derive this, right? And so I'm going to be I'm going to walk you through all the steps, right? Because I'm going to be very thorough. I guess that's the vocabulary word I should use. Because if you're young, you're in high school, and you're just watching this stuff for fun, hey, good for you. I want to make sure you understand each step, right? So, of course, if you're doing this yourself, I'm going to be doing a lot of obvious stuff. Go ahead and fast forward to the video if you see where it's going and see if you get the same result at the end, right? So the first thing we're going to do is we're going to make a variable substitution. So we're going to say, for example, u is equal to x plus y, right? So this is kind of obvious, right? The only reason I'm making this variable substitution is because now this is sine of u, which of course we can just use this formula over here, which is e to the iu, oops, and I forgot an I. See, I always forget the I. E to the iu minus e to the negative iu all over 2i. Oh, but you know, the wonder of the variable substitution is now I can substitute back in what u was. This is simply e to the I times x plus y minus e to the negative I times x plus y all over 2i. And so we are going to be using some exponential algebra, which I'll write down in a second, and we're going to expand this. So the first thing let's do is let's just expand this out. So if we expand this out, we get e to the ix plus iy minus e to the negative ix minus iy all over 2i, right? And so now let's introduce that exponential algebra I was talking about. You may remember that if you have the same base, then x to the a times x to the b is simply equal to x to the a plus b. Whoa, we have these two right here. This one looks a little bit hidden, right? And you may think to yourself, but Ramian, can't I just do the other one I know? This. You could, but we're going to make our life simple and we're just going to use this one here, right? So, to make our life even more simple as well, what we're going to do is we're going to factor out this 2i and just leave it on the outside for now. So, this is all equal to 1 over 2i times e to the ix, e to the iy, minus e to the negative ix times e to the negative iy, right? So now let's break down each term individually, right? In blue, we'll do this one. And then in green, we'll do this one. Right? So remember, with these negatives, the cosine stays positive, but the sign turns negative, right? So in blue, we get this now. We get I sine x plus cosine y, sorry, it's cosine x, times I sine y plus cosine y minus, oops, I like how I said I was going to color code it and I almost didn't, right? The fun of all of this. Okay, minus, and you might notice this green line right here. I tried my best to do this because I have a weird setup, right? Because I'm not a videographer. Anyway, so hopefully nothing gets cut off here. I tried my best to draw it out, but we'll see what happens. And then over here, and of course, listen to my words. If you can't see it, hopefully you can understand me. Over here, we're going to get negative I sine x plus cosine x times negative I sine y plus cosine y. Okay, great. So then now, just to be safe, I'm going to erase all of this up here. And I'm going to move up, right? Just so I can make sure I get everything on the video, right? So we're going to FOIL this out, right? So what we get is, and like I said, I'm going to be thorough. So if you can do this faster than this, sure, go ahead. Go ahead, do it faster, right? Remember, this is just for fun. This is just math for fun. This is just math for math's sake. This is just different ways to remember how to derive these formulas in case you forget, in case you don't want to look up in a book, right? Fun ways. So we're going to distribute. So we're going to get I squared times sine x times sine y plus I sine x cosine y plus I sine y cosine x plus cosine y cosine x. So that's this blue portion, which I will now erase. Okay. And then for the green one, and sorry for my sloppy handwriting right there, it's fine. If we reduce this down, actually let's reduce this down before we get into the green. So if we reduce this down, we know I squared is negative 1, right? So we're going to put a negative here. I have 2 copies of this, which you should know from your algebra, right? And in case you guys don't know the shorthand, a plus b squared is always a squared plus 2ab plus b squared, right? So you always get 2 copies of this. And no shock, I have 2 copies there, right? But I always in these videos will FOIL it out completely without reducing it back to formulas because, hey, the whole point of this is not memorizing formulas except for a few, right? So now this becomes 2 I sine x cosine y, I think. Let me make sure. See, that's the problem. I erased it too early. Actually, no. I messed up. Yeah, no. We don't get that. We don't get that here because unfortunately, that shortcut I just did messed me up. So we're actually having I sine x cosine y plus I sine x, I sine y cosine x, right? So we don't actually have that. We don't actually have 2 copies of it, right? Because it's an a plus b times a b, sorry, not a b, times a c plus d, essentially, right? And in this case, this is equal to ac plus bd plus bc plus bd, right? And so the b in this case is sine x. I did mess up. This is going to be sine x. I had it right the first time. So this is sine x. And then this c is a, no, I did have it right. This is a b in this case is cosine x, and c in this case is sine y. So there we go. So that's the difference, right? And the bd, okay, so we have the correct now. That's as far as we can simplify it. And so, I'm not going to edit that out just to showcase that, yeah, it happens, right? Sometimes when you write too fast, that's the beauty of paper, right? You have it all right there for you. Anyways, let's continue. So now, in the green, we have the same thing, right? So don't forget, we have a negative on the outside of all of this green. So we're going to keep that right there. And we're going to put it in brackets so we can remember. So now I get negative I squared. But because they're both negative, this should be a positive. But I got ahead of myself because of this negative over here. We'll get there in a second. So we get I squared sine x sine y. And then don't forget, on the outside of all of this, I have a 1 over 2i, right? So don't forget that. Don't forget that 1 over 2i on the outside. I'm going to write that up here just to remind myself. So I have an I squared sine x sine y. Then I'm going to distribute this negative I sine x to this cosine I. So this is, I'll just write it here just so I can make it easier when I do distribute that. So this is negative I sine x cosine y minus cosine x times I sine y. So minus I sine y cosine x plus cosine y cosine x. Okay. So now, before we distribute this negative, let's reduce down this I squared to a negative. And then now let's distribute the negative. So this becomes a positive, this becomes a positive, this becomes a positive, and this becomes a negative. And then now we can take this out of here and put a plus there. So let's go ahead and reduce what we can. So let's go ahead and in red we'll cross out the ones that are the same. So I see, I have a sine x sine y here and a sine x or negative sine x sine y here and a positive sine x sine y here. So these cancel. I have 2 copies of this sine x cosine y with an I on there. So this is going to equal 2i sine x cosine y. I have 2 copies of this I sine y cosine x. And then over here, I have a cosine y cosine x positive and a negative cosine y cosine x. These cancel. And then remember that 1 over I2 component. So remember, all of this is being multiplied by 1 over 2i. Whoa, lucky for us, that cancels out. So what do we conclude that sine of x plus y is equal to? I'll put it up here. We have concluded that sine of x plus y is sine of x cosine of y plus sine of y cosine of x. And I don't have this one memorized, so let's make sure this is correct. So I'll open up my handy dandy web browser. I'll go to wolframalpha.com. I'll put in sine of x plus y, and let's see what this is equal to. Let's see if it actually gives me some expansions. I get sine of x cosine y plus cosine x sine y. And that's what we have, ladies and gentlemen. Hopefully you found this video fun and exciting. And sorry for that mid blunder. You know, what happens sometimes when you go too fast is you make those blunders. So I almost made a mistake right here, but I caught myself. So hopefully you found this video enjoying. If you did, I don't know. Love math. I guess if you found this useful, I'm glad for you. All right, I'm about to make another video, so I'll upload this one now, and then I'll probably do some integrals of some products of sine and cosine next.